our last lesson, lesson 6. Okay, so this one is lesson 7. Okay, I should have written that, lesson 7. You talk about isotopes. Okay, we say isotopes and different variation of the same atom. Okay, that means having the same atomic number and different atomic mass. Example is carbon. Carbon 12,6. I think carbon 13,6. Okay, and you have copper also. You have chlorine 35 and chlorine 37. Okay, or 17. If you look at it, atomic numbers are the same. The only difference is the mass number. Exactly. The question that come in exam is calculate the relative atomic mass. Yeah. Okay, the relative atomic mass of carbon, the two carbon isotopes. The relative atomic mass, they will give you a question like this: how much they are in a sample, how much abundant they are. They can say they are in a ratio of 1:3 or 70:30. One is 30%, no, not a ratio. One is 70% in a sample, and one is 30% in it. You see, what's the relative atomic mass? That means what is the average mass? You get it? Okay? My own exam, GCSE O level, this is what came in the exam. Can you believe it? And the previous day, that's what I studied. Because our chemistry teacher, Mr. Boateng, he made emphasis on this. And some people are saying that he was one of the examiners. You understand? So he always emphasized on this, how to calculate the atomic mass. And it come in the compulsory. So Alhamdulillah Rabbil Alameen. I did it very well, okay? Now, the relative atomic mass is just the average mass. What you're going to do is, you are going to say, since this is how their ratio is, you're going to say 12 times 3, because this into that in minute, yes? Okay? 12 is 3 times, isn't it? 13 is 1 time, yes? Plus 13 times 1. All over. What's the total? The total one is 3 plus 1 is equal to 4. Divided by 4. You see? So this basically, mathematically, this is 3 times 12, 36 plus 13. Divided by 4. Look at my step by step, yes? Okay? So this is 49 divided by 4, isn't it? Am I right? Yeah. Am I right?
Yeah. No. Wait. Wait, how did you get 3 into 1? How did you get 3 into 1 in the ratio?
3 to 1 in the ratio. This 3 is the 1. 3, yeah, 3 of that. Okay? And that one will be 35 times 70 plus 37 times 30. All over 100. Okay? So, 4 into 48, we know it is 12 times, isn't it? 48 in the 1 into it 12.2, isn't it? So, the relative atomic mass is that. If you have a compound in which there are some carbon which are 12, some carbon are 3, when they are in that ratio, the relative atomic mass will be 2. Okay? You just find the average ratio. That one is a big number. Okay? I don't have a calculator. We should have a calculator. But this is how to do it. Okay? So, in the exam, something that can come. Calculate the relative atomic mass. We are going to do relative atomic mass. That will be maybe topic 10 years. Because we're going to do mass of a number. Like hydrogen, H2O. We know hydrogen is 1 because we say hydrogen 1 in. Atomic mass number hydrogen is 1 in it. Atomic mass of oxygen is 16. There's 2 hydrogen. That's 1 times 2. And 1 oxygen, 16 times 1. This is 2, this is 16. Mean water, the mass of water is 18 grams. This is called the relative atomic mass number. You get it? We do a lot of this later. When we do molarity, molecular mass, the formula of a compound in a solution, all those things, when we do atomic mass. So don't worry. Now my next topic is an ion. Look, in all the compounds, you see sodium chloride, calcium oxide, magnesium sulfide, okay, all these things, they all have something in common. They all have an ions, okay? Like water, you have H plus and O2 minus in it. This is called an ion in it. But it's one element, okay? But there are some compounds. Actually, water is not actually the way you say it. It's H plus and OH minus. Just for simplicity, that's what I did that. You understand? But most of them, they write like that. Because on OH minus is an ion of itself. They are called compound ions. And all the equations we are going to do may contain at least maybe one ion, one anion, okay? But some will be compound anions. That means compound negatives, like OH is a molecule, it's a compound. Oxygen and hydrogen combined together. But the charge is minus. Why? Let's see. We know that the number of atoms in a compound, proton, they may cancel each other. Now look at OH minus. Say this is our oxygen in it. Okay? Our oxygen. 2, 1, 1. Okay? Now, this oxygen is 2 minus because it needs 2 electrons in it. Okay? It needs 2 electrons. One more here, yeah? Okay. Here. Now look at our hydrogen. Hydrogen, oxygen. 1 here. 1. Okay? One here. Okay? 1. 1 electron in cell K. 6 electron in K cell L in it. Now let's say, because they are all 2 non-metals, okay? When they react, it's going to be what type of bonding? Covalent bonding. Okay? Now, if these 2 react together, okay, what we're going to have is our hydrogen and our big oxygen. Sorry. I have to make it different. Sorry. We have our small hydrogen. Okay? Don't laugh. Because it has only 1 cell, and only 1 electron in it. And we have our hydrogen, our oxygen here. 2, 2, 1. Now our Mr. Hydrogen comes. 1 electron, yes? It puts 1 electron here. And we say this is our Mr. Hydrogen, this is our Mr. Oxygen. Now, guess what? 1 is left.
Still not happy.
Okay? Still not happy in it. So, because electrons, their charges are minus, there will be 1 minus left in it. But this compound is OH. Okay? O and H. Or you can put it like this. Because the water molecule look like that. That way. Okay? So this entire molecule will be 1 minus. You see? Yes. It will be 1 minus. That's why OH is 1 minus. Do you get it? So it's like this. You have oxygen 2 plus. React with, oxygen 2 minus, react with hydrogen 1 plus. What would you have? OH, 1 positive plus 2 negative in it. Minus 2 plus 1. This is to minus 1. So the charge on the hydroxide molecule. They call it hydroxide. Okay, it's called
Is that the bigger number?
Yes, hydroxide. Okay, ion. A hydroxide ion. You see? Yes, that's why sodium hydroxide, see, OH, is N1Na plus OH minus 1 plus 1 positive, 1 negative. It will give you sodium hydroxide. Complete. Yes, but because of that, that's why you have 1 minus on the hydroxide. Okay? So all the compound ions we are going to do, they will have a charge. And the charge will all be the same. How to work it out? It all be the same, like this. Okay? Okay? Oxygen, this compound, okay, still need an electron. Okay? It can be provided by sodium, like here. It can be provided by another hydrogen. It can even be provided by calcium. You get it? But as long as it doesn't have 2 plus, it will remain 1 negative, because minus 2 plus 1 is called the minus 1. Okay? Many people, you won't find this in any textbook explained to you. They all assume, they tell you sodium, let's say sodium ion plus sulfur in it. Okay? Will give you sodium sulfate. Why this is 2, while this is 1? Some people say, okay, it is sulfur and oxygen. But actually, it's a sulfate ion. Because this may come from an acid, and this may come from a salt or a hydroxide. But the two compounds, how this is formed is, because sodium is 1 plus, SO4 is 2 minus. That's why I say the exchange balances. Sodium is 1, it comes here. This is 2 comes here. So sodium sulfate will be Sa2SO4. Because they exchange valences. Sodium is 1 positive. This is 2 negative. We need another sodium in it. Okay? So that there is 2 positive and 2 positive, it will cancel each other. But they don't explain this in the books like that. And simply, that is how what's happening. Now, how this is 2 minus, we'll come to know. Because how many oxygen do you have? 4.
Oh, yeah.
And oxygen is 2 minus. So if you multiply by 4, it will be 8 minus 8, or 8 minuses in it. Okay? So sulfur, that is coming here, should at least have 6. Okay? To make this 2 minus. You need 6 in each atmos cell. When they combine, it will be that minus. And the same thing as nitrogen. 1 minus. Same thing. When the minus is cancelled, positive and minus cancelled order, if there is 1 minus left, then that will be the charge in it. Okay. Now let's look at it. You must memorize this. You must know. Okay? You must know. And if you want, we can go over all of them one by one. Now, my last year students, I gave them the list. I don't memorize it, yes? So let's go through it. I have asked all my students, please go and memorize this, because I will be asking you from time to time. Okay? So if I were you, I get it down. I'm going to ask you this over and over. Okay? Now, I have the list here. Now, you know, most of the equations we do, okay, may contain these elements, okay? Now, let's look at group 7. The majority is group 7. Group 7 and group 6 and 6, or 6 and 7, okay? In most of these ions, they will be in 6 and 7 because they are the, why Why 6 and 7? Because they are the one which accept. Yes, 6 and 7. Sometimes 5. Okay, 5. Yeah, like I think neon. Yeah, it's in nitrogen, something like that. Now let's look at this. Okay, group 7. They are chlorine 1 minus because it is group 7 and it 1 electron. Look here, wait a second. Chlorine, okay, it is called a chloride ion. Okay, it's called a. You have to write this down because you have to memorize this. Okay, please. This is called a chloride ion. Chloride. Okay. Chloride ion. Okay. You have to memorize this. Okay. Another one is bromide ion. Minus 1 minus because it's in group 7 in it. It's called a bromide. So the compound that are formed from bromide and anything up 20. Let's go 4 minutes more. Okay. Bromide ion, it will call a bromide, okay? Example may be potassium bromide, okay? Potassium bromide or calcium bromide. Look at this attentively because calcium is 2. They exchange valency. Calcium is 2, it comes here. This is 1, it comes here. So calcium bromide is looking at like that. Another one is iodine, okay? 1 minus because group 7. And the compound that are formed from the alcohol iodide. Okay? You can have potassium iodide. 1, yes? Now look at our famous water that comes from water. It's called a hydroxide. Hydroxide. And example, famous one, sodium hydroxide. Okay? Look at me here. Now nitrate, potassium nitrate, is 1 minute. The compound formed there are called nitrates. An example is potassium nitrate. Okay, and you can have calcium nitrate. Mustafa, yeah. Calcium is what? In group 2. And is what plus up there? 2 plus in it. Yeah. So when they interchange valencies, what should nitrate be? Because nitrate is 1 minus in it. Yeah. What should nitrate be? 2 minus in it. Yeah. But you didn't ask this. Okay? Nitrate is 1 minus. Calcium is 2 plus. So exchange valencies in it. Yeah. Okay. The next one is nitrite. Be careful. Now what this is one. I'll explain to you later. It's called nitrite. You can have potassium nitrite, okay? Potassium nitrite. Okay? Maybe I have to do these things. Now, there's something called hydrogen carbonate. HCO3 minus, okay? This is called hydrogen carbonate. So the compounds which are called, they'll be, an example is calcium carbonate. This is chalk. The chalk we used to write on the blackboard is calcium carbonate. Okay? Then you have a sulfide ion, S2 minus. Okay? And it's called sulfide. Sulfide. And you can have ion, Fe, sulfide. Okay? That will be 2. That will be 3. That will be 2. Okay? Now, we are not finished. There is phosphate. I don't know where to put that one. There will be phosphate, PO4. PO4 is 3 minus. It's called phosphate, potassium phosphate in it. Phosphate. Example is potassium phosphate. Potassium phosphate is fertilizer. Okay? Potassium phosphate is a fertilizer. Do you get it?
Like manure.
No. This is a manufactured fertilizer, not manure. Manure is organic in it. Yes. So we are not finished. Have you written this already?
Yeah, I don't know that.
You are finished with this? You are not finished. You are finished, yeah? I would like people, maybe they can post it, yeah? People may be looking online, they can post it. Most of you do get it? Now our famous one, because when I say famous, it means they appear very often in it. SO4 2 minus. And they call this sulfate. So the compounds formed from this are called sulfate, potassium, sulfate. Mustafa, why is this 2? Why K2?
Because it needs 2 to bond with that.
Because SO4 is 2 minus. So you need 2 positive in it. So basically it will look like this. K plus 2SO4 2 minus. Sorry. Not 2. Potassium in it. Yeah. So that 2 positive, 1 plus 1 minus 2 is equal to 0. And all compounds must have 0 charge. If not, they'll still attract. That's why cancer, you know cancer? Because you have free radicals going in your body. And they want to snatch electron to become stable. Okay? So, if they don't, they can snatch it in some of the mineral inside your body. And they may create some unwanted growth. So that's why if you drink lemon or grape and so forth, they have a lot of you are doing antioxidants. Antioxidants. Because they are rich in free, positive or negative, that we can react with the free radical. Okay? Sulfate. Okay? Now, sulfite. We have done that one. Okay? We have done carbonate. We have done sulfide. Okay? We have done phosphate. Okay? I think
we have done sulfide.
We have done sulfide. Sulfite and sulfide. This is SO3. 2 minus is sulfite. The other one is sulfide. Sulfide. Okay? This is sulfite. Now S, like potassium sulfide or potassium sulfide, is called potassium sulfide. Be careful.
Yeah.
Potassium sulfide. And potassium sulfide is different. Okay? And potassium sulfide is different. Okay? Now potassium sulfide will look like this also. K2SO3. This is potassium sulfite. So this is the sulfite ion. Okay? Everything is ion. Sulfate ion, sulfite ion. Okay. We did CO3, this carbonate ion in it. Okay? O2. And is O2 a compound ion?
Yeah.
Is O2 a compound ion? Halima, is O2 a compound ion?
No, it's one element.
It's only one element.
Yeah.
You understand? So it's not compound ion. No? So its compounds are called oxides. And famous one is calcium oxide. Lime water. Okay? Use a test in the test for carbon dioxide. Okay? If a solution, you want to know whether if you burn something, carbon dioxide comes out, it's a product, you pass it through lime water in it. Yes, when you pass through lime water, what happened, Halima? We did it last year in it. CO2, what happened? You'll have a cloudy precipitate. That's the right word. If you want to do chemistry, you must use the right word. The cloudy precipitate is chalk. It's chalk. That's why you have a cloudy precipitate. If you pass the carbon dioxide, let's say you do an experiment. I'm not very good at drawing. Okay. maybe they say it's a cooler. Okay, goes through this thing.
Gas range.
This is a gas, isn't it? Okay. Now, if you
That gas range.
yes,
Yeah.
that's the fire. I'm not good at drawing, and you boil something, yes, and the gas pass through. If it passes, it goes to some where calcium carbonate is, calcium oxide is. Okay, there'll be a white bubbles, a white precipitate in it, and the white precipitate is calcium carbonate. Okay, I'm not good at drawing, but the gas will pass through this. Yeah. Okay. Let's see if this is one unstable stuff. Yeah. Yeah. So it will burn it, and then the gas will go out. Innit? Yeah. You pass it through lime water. And this is one of the tests in the laboratory for carbon dioxide. Carbon dioxide. Okay. Oh. So I think we have finished this. Yes. Yes, we have finished this. Mustafa, you have to memorize this. I'm going to ask you nitrate ion. What's nitrate ion? What's nitrate ion? What is the charge on them? Remember, 1 minus and NO2 all 1 minus. Yes, one is nitrate and one is nitrite. Some nitrite, some O of ion are in ferrous nitride. Okay, ferrous nitride. Okay, I'm going to ask you about this very often, because when we do what's the word again? When we do a reaction or an equation, don't ask me why is this Na2SO4? Why? Don't ask me. That's why we do this before, because you need sodium is 1 positive and SO4 is 2 negative in it, 2 minus, yes? And you need another Na to make this N2SO4. Okay? So if you don't do this before we do reaction, when I give you famous neutralization reaction. What's neutralization reaction? Reaction between an acid and a base. Okay. When I give you zinc hydroxide, okay, no, that's not a good one. Potassium hydroxide plus sulfuric acid, okay, SO4. When in the neutralization reaction, you always have a salt and water. So this will be potassium sulfate plus H2O. Okay? Potassium sulfate plus H2O. Don't ask me what is SO4. Okay? Why is H2SO4? That's why I give you this thing before, and in the books, they don't give you that. Simple. SO4 is 2 minus. Hydrogen is 1 plus. Because it's 2 and 1 minus, you need another hydrogen. That's why it's H2SO4. That's right. Okay? So that's why before I do equations, I say let's deal with this first. And the next time we are going to deal with ions. Okay? What we did were anions, negative charges. Okay? The next time we do, we're going to do the positive ones. Cations, okay? Cations. Do we have time? Can we extend this to 30 minutes? Okay. Let's end it there. And the next lesson, because I want to also finish this topic before we go revert back to mathematics. Okay? I want also finish this topic, because we want to go exactly according to the syllabus. Okay? So that there's nothing left. Is this the 9-1 book, yeah? Yeah. Relative atomic mass number of isotopes and compounds, yeah? What are compounds? We will do that later. Huh? We'll follow all these things properly. Then chemical equation. What are compounds? We read about compounds, yes? when element react, okay, can you stop there? Yeah? Can you stop there?